So, quiz question. How many lines of code do you think were written in the creation of this game? We'll come back to this soon. To introduce myself briefly, my name is Daniel. I'm here with the Endless Foundation. We have a decade of experience running all kinds of different digital empowerment projects around the world. We take education and technology into places where access to such things is limited. And in recent times, we're really excited because we've been starting to take groups of learners and we've been kind of getting them into Godot game building. Now, we're really excited about this because I think everyone here knows that if you're in a team building a game, you have to develop all kinds of skills, right? There's coding, there's artwork, there's design, there's 3D modeling, there's music composition, storytelling, project management, the list goes on. So not only is it really engaging and exciting for the participants, it's a really great way of developing a whole range of skills. For a little bit more on the education side, I'd like to hand over to my colleague Justin, who is an experienced educator in technology.
Hi, everyone. As Daniel said, we're running educational programs for students really all over the world. And one of our core principles in our programs is that everyone belongs. And because we're casting such a wide net or have such a broad learner profile, that also means that among those learners, the majority of them have never coded, have never seen a game engine, and are also new to game design. So despite all of these wonderful things that my colleague Daniel just described coming from exploration of game design, and us wanting these students to see themselves in this world and benefit from that, they don't see that at first. What they do see is something like that. Among our team here, I'm probably the least technical person by several kilometers. So, but what that does do is it provides, I'm uniquely positioned to have a little bit more empathy for these learners as they first explore what, like I said, what really does look like that to them when they open a Godot engine for the very first time. And one of the additional challenges when they see that is that they haven't really been given a motivation or a reason to care about those knobs and dials yet. So it sort of skips the point. So as an educator, as soon as I saw Godot for the first time, I thought, okay, Godot, game design, and GDScript all at once, brand new for a learner, and I haven't yet told them why it's cool or why it's worth sort of fighting through that. That's sort of backwards for me. So what have we been trying to do? Essentially building an on-ramp into this world. And with the goal of keeping the focus for the students on that motivation, that engagement, and more about creativity and ideation and less about the tool. Because that does sort of naturally happen to them. Even if they start out excited, the tool becomes so overwhelming that they sort of hyper-focus on that and get overwhelmed by it. We've seen in a lot of our programs that we've run, even at higher level education, even in some college programs, that the initial excitement kind of drops off, the engagement, the confidence drops off as soon as GDScript, it becomes apparent that you really do need to know a good amount of GDScript to move forward with a game. So to try to help with that, to try to ease those early moments in the game engine, we've done a couple of things along a kind of spectrum, one of which is that we've deliberately designed some moddable games that are designed with these learners in mind and have a focus on sort of just playing around in the tool and exploring the UI, but through exploring game design elements, like basic introductory game design elements. And as students start to get a little bit more comfortable with the very basics of those panels and that UI, the other thing that we've introduced that you're going to see a demo of in a moment here, to further extend that time that early learner can be having fun and making games start to finish, is block coding or visual scripting. So, Daniel?
Great. Thank you, Justin. So before we jump into a live demo, I'd just like to spend a couple of minutes explaining what this is and what it isn't. So what block coding allows you to do is it allows you to get into Godot as a beginner, but you don't immediately have to get into the world of programming in GDScript, right? You are able to use this plugin in order to build your game logic with blocks. However, we do not envision and do not target this to be a replacement for GDScript, right? That will always be a more powerful approach. What we're doing is designing this as a learning tool, which could be used as a stepping stone along the way. As you're getting into Go, getting into game building, you're able to get started with this and perhaps then move on to learning GDScript at a later point in time. We also do not attempt to replace the main elements of the Godot editor experience, and it is therefore crucial that learners get familiar with node types, scenes, what's a rigid body, what's a static body, how do I use the inspector, how do I animate things. We don't replace any of that, and in fact, block coding is a really nice complement to all those things. You can put those things together and build some really interesting little games. So what we've kind of introduced here is actually, in some sense, a new programming language. It's a visual one. It's heavily inspired by other projects such as Scratch and MakeCode. You bring out these blocks, you snap them together, and that forms the logic for your game. The language that then we're implementing here, we have some kind of design constraints and goals, and we're really leaning into this being a learner-friendly language. So it was very interesting to hear yesterday morning, Juan mentioned that one of the reasons that visual scripting was removed from Godot 3 was because it didn't meet the expectations of people who were expecting some type of pre-built components. So we're actually working in that direction. We call it high-level abstraction. One example is the block you can see at the top here. If you just want to move your character sprite around the screen, you drop in that one block, move with buttons, and then your player will move around the screen. You haven't had to think about time delta, vectors, input events. It's just much simpler, much quicker to get started. Secondly, we are, for the most part, avoiding technical terminology. And again, to make it easier for learners who are new to this, we're using more of a natural language approach. So if you've ever worked in GDScript, you probably know what body entered means. Well, in our language, we're referring to this as when this node collides with something. It's our understanding and belief that when learners later make a transition into GDScript, the difference in terminology will be very easy to grasp because they will have a conceptual understanding of what this is. So I've hopefully kind of given you the idea that this is not for everybody. If you already know GDScript, this might not help you. But there is a community of learners that we've experienced, and also as we posted this online and got some great feedback, there are people that want to be involved in building games in Godot, but they are struggling with the friction around learning to program. So that's the kind of audience that we're reaching. We've had some excellent feedback, including someone that's told us that our plugin was like the introduction of fire to civilization. So back to the quiz question. It's probably obvious at this point, but that game we showed you was written with 0 lines of code. It was entirely built using blocks and, of course, the regular functionality of Godot. Before we jump into the demo, I'd just like to add one disclaimer. This is early-stage software. It's buggy, probably missing some pieces, needs more polish, etc. At the same time, I'm really excited and impressed with the diversity of games we've already managed to implement using a small number of blocks. Thank you very much. I'd like to hand over to my colleagues Cassidy and Dylan.
All right. We are going to build a game live, do a live demo of block coding on stage, and everything's going to go perfectly, and it's going to be great. This mic is already being great. So we're going to build a side-scrolling spaceship runner, avoid the obstacles, collect gems, that sort of deal. And first, we're going to make sure the editor is nice and arranged here, set up well. Yeah? Close when you open, maybe. See, live demos are great. This is why we do them. And yeah, so we've prefabricated a lot of the assets themselves. So we've set up scenes and things, but we haven't implemented any logic or any mechanics yet. And so that's what we're going to do live. Cool, we're all set up. So first, we have this main scene here in Godot. It's a normal Godot scene. We can even play it, and it's just a scene. There's a spaceship. You press buttons, nothing happens, but it's got a little, particle emitter thing going on. And let's actually add some logic. So we're going to open the ship scene, This is a simple character node type that we've actually added with a block coding plugin. This is one of those high-level node types that help simplify things. And it's a high-level abstraction for character movement. And we're going to make it move around to the keyboard. Or we're going to struggle with live demos.
Yep, I just can't be full screen. That's fine.
OK. Which maximizer?
Nope, I just got to close that guy once again. IDPI. All right.
There we go.
Okay.
It's fine. Live demos are good.
That's why we do live demos.
So we're going to make it move around the scene, or move it around the scene with the keyboard, and we're going to do it with the block coding plugin. So let's go to the block code on the ship scene. We're going to go to the block code bottom panel. This is something we've added with the plugin, and we add block code. Super easy to do it. And blocks live under a specific node and act on that node, similar to how you would attach GDScript to a node. And we're going to add an every frame lifecycle block there from the side, and attach a move with buttons input block. And that's it. We have easy movement without having to worry about handling input events or calculating vectors. We can demo that scene. It moves with WASD. Neat. And then, yeah, so let's add some animations. Let's see how that works with animations. Godot's built-in features like animations are key to making block code games. So let's add a little wobble to the ship. So again, we've prefabricated the animation itself, but we're going to open select the animation player node and play that built-in wobble animation. And again, we open the block code panel, and we hit add block code. And since this is an animation player that we're working on, we actually have animation blocks. So the available blocks depend on the node type that you're working on. So we're going to drag out a play animation block and select the wobble animation. And now when you play it, it wobbles. Ta-da, it wobbles. Cool. All right. But now we need obstacles. It's not a game if you don't have obstacles, right? So we've built a scene here. We're going to open the obstacle scene from the file tree. It's not in the main scene yet because we're going to spawn it. And it's plain Godot. It's a plain Godot scene with what you'd expect. It's a rigid body with collision shapes that we've set up. And in the inspector, we've set a linear velocity for leftward movement, so it flies across the scene. And we want to spawn this scene repeatedly in random positions during the game. So we're going to start just with a spawning. So we actually have if we go back to the main scene, we can add a simple spawner node. Again, this is a high-level node that we've added that spawns scenes on a timer. And we're going to place it on the right side of the scene, somewhere around like 1,000, 250. Drag it out there, yeah. And we're going to configure this to spawn the scene with the appropriate settings. We can just do that in the inspector. So we'll select the inspector or the obstacle scene, and we'll set the spawn parent to the scene so that the obstacles can move independently of the spawner. We'll wait for Dylan to catch up, not get too far ahead here. And then we'll just set the frequency to 3, which is every 3 seconds. So every 3 seconds, it'll spawn that scene, and it can move independently from the parent node. Then we can add the block code node. So again, the block selection varies depending on what node type you're working on. So in this case, it's a simple spawner. So we have a start spawning block that we can add. So we say when starting, start spawning. That should be all we have to do to get the spawner to work. So let's demo this and see if we have something that's starting to look a little bit like a game. Hey, it spawns the obstacles. And you'll notice we have collisions because there are rigid bodies with collisions, but nothing happens when you crash, so that's not very exciting. So maybe we can handle those collisions and do something with that programmatically with blocks. So let's handle those. We're going to go to the ship scene. We're going to handle the collision with the ship. And we are going to select the animation player. We have a crash animation we want to play. So let's play the crash animation. It's all good.
Why do they keep doing this?
Windowing is being weird.
Yeah, this window's being bizarre. It's only when it's after I play the game in full screen.
Oh, yeah, don't full screen it.
I didn't this time, but it's been that.
Live demo.
Yep, live demo. Editor bug. Yay.
But you'll note it's not the block coding that we're having trouble with. So it's just other normal technical difficulties. It's fun.
That's all good. Okay. Ready?
All right. So we want to run the scene and show the, or we want to handle the collisions. Sorry, yeah, handle collisions. So we're going to select the animation player node on the ship, and we're going to play the crash animation to show what that looks like. Cool, it crashes. And for this, we're going to define a crash method that will play the animation, and then we want it to remove the parent node. We're not doing the remove parent node, are we? So we're just going to play the crash animation. And so we're going to add a define method block from the communication methods section, and we're going to name that method crash. And then we can add a play animation block, and we'll play the crash animation until done. Okay, and then we have to pass along that crash method from the ship to the animation player. It's a bit awkward, right? But we're going to add a define method block from communication methods on the simple character. Yep, you're already on there, aren't you? Yeah, all right, I'll just keep going. And then we're going to call method in node, and then we're going to drag the animation player node from the scene into the canvas. You can drag nodes from the scene to get references to them, which is pretty cool. And we're going to select the root simple character of the ship and add it to the, oh, sorry, I jumped ahead, yep. We're going to select the root simple character of the ship and add it to the ship group. We're using groups here in Godot to help communication between different nodes and scenes, so it's a nice kind of shortcut there. And now we want to go back to the obstacle and actually call that method, right? So we're going to select the area 2D node in the obstacle scene, and we're going to add block code here. And we're going to add a when this node collides with something block from communication methods. And we're going to attach an if block from logic conditionals. This is going to be cool, promise. And we're going to put a node is in group block into that conditional and as that condition. And then if something dragged from that block above is in the group ship, then we want to actually call the method crash on that ship, so on something. So you can actually, that something is a dynamic node block that we can use as an input on another block that accepts nodes, which is pretty cool. And behind the scenes, this defines a callback function, then connects to the body entered signal in the ready function. And we can demo it. So now, we have a crash, if you're still with us. But the game looks a little too easy, right? You can just sit there in the middle and fly around. So let's keep going if we've got time, right? We've got a couple minutes, I think. 5 minutes? 5 minutes? OK. All right. We're going to do the, well, we won't do the coin part. You can come back to our booth later and see how to add coins and scoring to it. But we're going to do one more thing here. Let's randomize that vertical position of the spawner so that it makes it more difficult. The spawner will move around and then spawn the obstacles at different places. And this starts to show how blocks can be used to implement a little bit more advanced behavior. So we're going to go to the main scene and open the simple spawner block node. And we're going to add an every frame lifecycle block. And we're going to set the position block. Sorry, we're going to add a set position block and to a vector 2. And let's set the x to like 1,000. And then the y, we can actually get the random floating point between two numbers block. Which starts to get a little long here because we're doing some interesting things. But we are trying to use more natural language that learners will be able to recognize. And yeah, between 50 and 500 or something, yeah, sure. And then that should actually be all we have to do to move that spawner around. So it should, every time it spawns, it's going to spawn at a different place when that spawner is moving up and down. Yeah, look at that. So, with just a few blocks, we have something that sort of resembles a game here, and you can crash and lose, But yeah, come back to our booth and see the next part of it with coins.
Thank you very much, Dylan. Thank you very much, Cassidy. That was amazing. Just to close quickly, just like to add, this is an open source project, so the code's on GitHub. Contributions are very welcome. It's available in the Godot AssetLib, so if you want to add this to your project, just go to the AssetLib, search for block code, download the plugin, install the plugin, enable the plugin, and then you'll get the block code thing in the bottom section for every single node type. Also, if you go to the AssetLib from the project manager section of Godot, you can actually download and install the block coding demos. So we have like 5 games similar to the ones you've seen today, built using the same types of mechanics, the movement, the spawning, the collisions, the animations. Those components, you can build a whole variety of things. We've got some demos there. Quick shout out to William Baumgartner, who was our summer intern a few months ago. He really got this project on the road for us. And today we have 10 people from Endless. We have a booth just down the hall, so please come to us. We'll show you the rest of this game. We've got other games. We've got other learning tools we use. We'd love to help you build your own game with blocks. We'd love to talk about how we can build a scalable open source game building learning community. It'd be great to have you at the booth straight down there. Thank you very much. Yeah, we have 2 minutes. We have 2 minutes remaining.
Like a minute or two? Yeah, why not? Okay, we're gonna do the last part of the thing. You can come ask us questions at the booth, but this is gonna be more interesting, I think, if we can do the last part of this game, because it's really satisfying to finish the game, right? Okay, we're gonna go through it really fast, and if we get kicked off the stage, that's fine. So we're gonna implement scoring. We have a nice pre-made gem coin thing. We're gonna add it to the spawner and implement some scoring logic, so we can add the coin to that same simple spawner that we had that's spawning the obstacles. And when you add a scene, it just will randomly pick between the scenes that you add, so it'll spawn randomly between them. So we're kind of reusing the same one there, just for time. And we'll use a simple scoring node, which is another node we've added to the block coding plugin to simplify scorekeeping and display. And we're going to define, and yeah, I'm not doing this in real time, I'm just saying what's going to be happening up there in case we're not in sync, that's fine. We're going to define a method to be called here that increases the score. And then back on the coin scene, on the animation player, we'll define a method that will be called to play the coin taken animation, so it goes bing. And then on the area 2D, we'll handle the collision with the ship and call those methods that we just set up. And then we'll do a final demo in about, like a minute. So it'll be good. So see if you can kind of see what's going on here.